I will now show how to determine a basis for the image of a matrix using the reduced row echelon form of this matrix A. And we will look at the same example as we did for the kernel of a matrix A. And we have the following reduced row echelon form of A. Well, recall that actually the image of a matrix A is the column space of the matrix A, which means that the image consists of all linear combinations of the columns of A. So now the question is, what columns of A span the image of A and are linearly independent? Since then we would have a basis for the image of this matrix A. Well, recall that actually if we look at the kernel of a matrix A, then the kernel of a matrix A is the same as the kernel of the reduced row echelon form of A. And this means in particular that the linear relations between the columns of A and the columns of the reduced row echelon form of A are the same. Since non-trivial relations are non-trivial elements in the kernel of a matrix A, which therefore also should belong to the kernel of the reduced row echelon form of A, and vice versa. So the linear relations, if you find a linear relation between columns in the reduced row echelon form in A, then we also have one for A. And notice that we have here two pivots, and we have constants C1, C2, C3, C4, C5 corresponding to these columns. We have 5 columns, and we see that actually the second column is 2 times the first column. Indicated by this 2 is 2 times 1. And similarly we find that we can make C4 by having 3 times, making 3 times C1 minus 4 times C2, C3. And C5 is no more than minus 4C1 plus 5C3. So we also have, if we call the columns V1 till V5 in A, we have the same linear relations between the columns. And actually here we see that the second column is 2 times the first column, etc. So actually from the set of columns V1, V2, V3, V4, V5, we have a couple of redundant ones, that is V2, V4 and V5. So the image of A is a span of V1 and V3. And of course V1 and V3 are independent, since these are pivotal elements. These are independent. There's no linear relation between V1 and V3, since then we would observe the same linear relation in the row reduced echelon form of A. So now we may take as a basis V1, V3 as a basis for the image of the matrix A. So actually a basis can be read from the reduced row echelon form by tracing where the pivots go, in which columns, and we can find them back in the original matrix of A.